Good morning, everybody. Hello and welcome to our next webinar with the topic Application Module ABLS 2.1 and Application Module ABZS 2.1 and the Logic Module LMS 1.1. Yeah, my name is Thorsten Reibel. I'm sitting here together with Jürgen Schilder. And as always, we share this webinar, which takes around 1 hour. Before we start, some organizational topics. First of all, yeah, you can give us any questions in the chat room on the lower right side. You can write to us what you ever would like to get answered. We try to answer during or finally at the end of the webinar. If it's not possible, of course, we send you all this feedback email. Then we try to, or we will answer your question in this feedback email. As always, at the end of the webinar, there will be a questionnaire, a few questions about our topics from today. And so please answer these questions as well to finalize this webinar. And yeah, if you cannot do this right now, we will remind you latest in our feedback email to do this with also the link to this questionnaire. Yeah, application modules and logic modules. So today we will do it the following way. I will start with the with the logic module LMS 1.1 and followed by the logic module LMS 1.1 followed by the application module ABZS 2.1. I will show also the functions inside the ETS, and Jürgen will show you maybe the most important application module ABLS 2.1, also with an introduction into the design and the commissioning in the ETS. So we will show you everything live on the ETS, followed finally by some examples, some solution examples of the ABLS, which might be quite interesting. Good, let's start with the first slide. Yeah, logic and a lot more. So you see here a typical simple logic, which is part of our solutions, but you will see in our components, and the 3 components are much more than logic. Of course, also logical functions, you might know from PLCs, but a bit more is available depending on the product. So if we talk about building automation, modern intelligent buildings, there's not only switching and dimming and simple functions necessary, but more and more, intelligent functions, which has to do with logical gates, with any time functions, with comparison of values, for example. So more and more intelligent functions are necessary. And with these basic functions, we can create with these components, intelligent final functions. You will see later on some examples, like again, logical operations, but also interlocks means you can enable and disable any functions, for example, or you can process fault signals, and many more functions are possible. Or here an example, telegram multiplier. We will see how it works with our components, sequence functions. Also here we will have an example. So a lot of different intelligent functions are available together with these components, which you need more and more in our powerful solutions together with KNX. And ABB offers a lot of components doing this job. And you see here also our traditional components on the lower side, like DIMM and switch actuators, but also our new presence detector and any push buttons. They also have some intelligence inside. So independent of their own function, they offer you some kind of logical or further intelligent functions. So not only our dedicated components, you see here an example on the upper left side, our application units or logic module have this function, but also these traditional or conventional functions. But what is the difference? Why is sometimes this integrated solution in these classical devices not sufficient, not enough? These solutions inside these components are not powerful enough sometimes regarding quality, but also quantity. Sometimes you need more inputs and you cannot have or cannot use this internal logic anymore. So you need some more logic, for example, or some more intelligence. In some projects, due to security reasons, separate components are required for this additional intelligence. It's a significant part of the total solution. If it does not work, then you might have a problem in your project. So it's not accepted to have double functions. Traditional function of a push button, for example, plus logic inside this device. If you have a complex logic and you need a lot of devices with these conventional devices or classical devices, you might have telegram traffic over line or area couplers, which also causes more traffic than you would like to have. And also this is an argument to say, no, I would like to have dedicated components, it's a powerful intelligence inside, and I have less traffic over couplers, for example. Yeah, and then a big topic is documentation. You see here already a solution, a graphical solution we have with our application unit, compared with a more text-oriented solution inside the other devices. It's not so transparent, not so easy to document this. And it's also an argument to work with the other solution. And last but not least, we will see it later on in our example with the ETS, the handling, the overview, design process is much more user-friendly. Yeah? Especially if you have a comprehensive intelligence or logic necessary, where you might need a lot of classical KNX devices with their intelligence. You have a very bad overview, and that's not easy to access. So there are some arguments to work with these separate dedicated devices, but nevertheless, you have, of course, and also in these other devices, some logic and some intelligence available you can use, of course. So let's have an overview of our three devices: logic module LMS11, application unit ABLS 2.1 and ABZS 2.1. They look very similar. They are, more or less regarding the housing, the connection, the same. Only bus connection is necessary, but be careful, hardware is not the same. So you cannot download into a logic module LMS an application of the ABLS, for example. It does not work. There's a difference in hardware, different memory inside, maybe also different processor. So it's not really the same. So one hardware, of course, and one software belongs together. So let's start with the logic module LMS 1.1. There's only one ETS application available, logic threshold scene. Yeah, let's have an overview. What is inside this device? All these devices are not new. Yeah, these are relatively classical KNX devices in our ABB range, but they are not obsolete. They are still very often in use. And we decided to have a webinar also about these devices, just to refresh your knowledge a bit maybe, and maybe to give you also some new information, what is possible with these devices. So the logic module LMS 1.1 has 12 different functions. And one of these functions is logic, but you see much more: gate, time functions, format converter, for example, counter. Yeah? And out of these 12 functions, you can select 3 in one LMS. Block A, B, C, 3 out of these 12. You can say also, okay, I would like to have 3 times the same functions, also possible. Yeah? But in total, only 3. And if you need more of these special logic, maybe you have to add another logic module LMS. Let's go into some details of this component. You see here another screenshot. I don't go into the ETS with this device. We will concentrate on the application unit in the ETS. But you see, if I've selected logic, for example, for block A, then I can select which kind of logic I would like to have, and some more adjustments here for the in and outputs. And of course, if you go to the communication object, you see all these, in this case, 6 logical inputs and 1 output available. And numerous parameters, of course, available for these functional blocks. Yeah, let's go in some small details of these 12 functions. Logic, I mentioned already, and or, exclusive or, not and, not or, equivalent, and up to 8 inputs are possible. And here I've written a few examples what could be done. Classical logic, connection, for example, of local push button with brightness sensor and function, or indication whether windows open. There you need a classical O or function, for example, to show whether any of the numerous windows are open. Gate filter, Jürgen will explain later in the ABLS this function a bit more detailed how it works. In principle, you can enable and disable telegrams. That's a very nice and important function. Example here, in an events hall, a local push button for operating light should be blocked at a certain time. So during any performance, nobody should operate any light. So it's very simple with this gate function and can be activated, deactivated, this local push button in principle. Time delay, nothing special. On-off delay, you might know from switch actuator. So that's not really, let me say, special, but also sometimes necessary. Multiplier, what does it mean? Out of one telegram, you can create many more different telegrams. So one telegram goes into a multiplier, 1 bit maybe, and then 1 bit, or here also 1 byte telegrams will be sent out. Will be shown later in the ABZ also as an interesting, more powerful function in this device. So for example, a fixed light scene could be created. So sometimes quite nice function. Min-max value indication, what does it mean? Out of up to 4 values, you can find out what is the minimum, the maximum, but also the average value out of these up to 4 inputs. Example here, in a big room, you have to create temperature control, and you measure at different points with different temperature sensors. And for example, the lowest measured temperature should be used for temperature control, to have the right temperature in the room. Or maybe also the average value could be also possible. You can compare also temperature values up to 2. So example here, you would like to have intelligent cooling down of a building with electrical windows. To do this, you have to compare the inside temperature in the building with the outside temperature outside. So, and depending on the right relation between in and outside temperature, you would like to open the window for cooling down. So outside temperature have to be lower than inside temperature, for example, and then you open automatically in the night, maybe some windows to ventilate the building. Threshold values, you know, also from our analog inputs, for example. So if you have any dynamic values, you would like to create a threshold. So in case of overshooting or undershooting, you would like to take some action in your installation. For example, here, if a brightness value is exceeded, the blinds will go down. Of course, some of these functions you have already in these in and outputs you have in use for any intelligent building. But sometimes, again, this function is not powerful enough, or you have it not available due to any reason. So they can use these external logic module. A very special function is a format converter. What does it mean? You can convert different data types. Example here, 1 byte. You would like to read out each bit of this 1 byte value. For example, you would like to read out a status byte. And in a status byte, each bit has a dedicated information. And you would like to display it anywhere in the visualization, for example. So this way you can read out, for example, each bit of this 1 byte. There are more, let me say, format converters available. It's a bit special, this function, but in some cases, it's necessary. Light scene management also integrated here. You know from other components, of course, from push buttons as well, but also here, very powerful integrated. And the last 3 functions, toggle means you have 2 values available are sent to this logic module, and you would like to switch between these 2 values. For example, here, between 2 set points in the temperature control, you would like to switch easily with a local push button, for example. Then we have the counter functions, also existing in binary inputs, but also here very powerful. So counting means you count telegrams. Could come from any light barrier, for example. If people enter a building, you would like to count the number of people, or you have any meter, conventional meter with a pulse output connected to an input, could be also used here to count the number of pulses and the value behind. And last but not least, a classical staircase lighting function. So you switch on a light, and after a certain time, adjustable, of course, light will be switched off. Also, I think well known from the switch actuator. So let's summarize. Some functions are very well known from other components, maybe not so often in use, but here also some special functions you do not find in other components and inside this logic module. Okay, let's go to the next component, the ABZS 2.1. The application module with time functions and group functions. So before I go into the ETS, I have a kind of summary of the functions itself, what is behind this component. First of all, there is a huge timer inside, a multi-channel timer, where you can adjust day routines, week routines. I will show how it works inside the ETS. Up to 15 day routines can be created with 800 switching times. So it's really a huge timer. And sometimes special days or periods are necessary. Remember, if you have any holiday period, we would like to have other switching times can be created as well. And in many regions of the world, we have this so-called daylight saving time or summertime can be adjusted here as well. But I will explain how it works together with a timer, internal timer of this device. Yeah, because we have an internal clock available, but also we can send out the time or receive the time from anywhere on the bus. So if you receive from any other standard timer, the time, then you don't need to maybe to change daylights here, saving time in this device, because it's done automatically by the external timer. Yeah, so multi-channel timer. But the second function is grouping. And what's behind? Remember in the LMS, I explained the telegram multiplier. So one telegram in and many telegrams will be sent out. And this is a really, very powerful solution also here inside the ABZS. We call it group function here. Yeah, and whatever you have done later on with your time program and your group functions will be visible. What have you programmed? The utilization will be visible, but I showed to you this as well inside the device in the ETS. So here a screenshot of the ETS application. It's a plugin, but again, will be shown to you live. What is a day routine? A day routine in principle is a time switch program for one day. So at any time you switch on or off something, and this is happening the whole day. So between midnight and early morning of the next day, and this can be adjusted here. A day routine will be assigned to a week routine, means the 7 days in the week have different day routines. So maybe working days from Monday to Friday are the same, but during the weekend you might have a different time function. Again, these special days, holiday, for example, can be created with totally different time functions. Yeah, and the group function. In principle, a functional group is a combination of group addresses which are sent out at the same time. Telegram multiplier in principle, but very powerful. You will see. Same time, yes, you can send out very quickly all the telegrams, but that can cause some traffic problems maybe in your ETS or KNX installation. Adjustable is a delay, a telegram interval between each telegram sent out to delay the traffic or to reduce the traffic. That might help in some cases. Yeah, and inside the group, you have group addresses as members, of course. And the group trigger is a group address which activates the group, which activates the numerous telegrams sent out from this device. So we will see inside the ETS that not only an on-off telegram, also 1-bit telegram can trigger a group, but also a value. So if you overshoot a value, temperature value, for example, you go over a dedicated temperature value in the room, then you send out a group. There's a lot of functions behind. It could be done as well. But you will see the flexibility inside the ETS. I will show to you. Yeah, example for such groups. For example, you leave your house, you have an absence button. And if you press this button, a lot of different functions should take place. For example, it's also combined with an alarm system. You activate your alarm system, you set your alarm system. You send these setting telegram to the ABZS, to the group function, and then different functions take place. You see here some sockets will be switched off. Night mode of your air conditioning or heating system will be activated. Some blinds will go down. You will block the water supply outside your building. You switch off maybe also lights. So simple on-off functions take place as group members. But we are flexible. I mentioned this already. Another example, you can create a very powerful light scene this way. Means by the telegram or the group trigger, a 1-bit telegram as well, you send out values for dimming some lights in the building. So you go to dedicated brightness values. Or you switch off a light as well, or on, whatever you want. So a combination of 1 byte and also 1-bit telegrams are available. Only examples, but much more functions are possible. You will see later. Here another solution I mentioned already, the group trigger can be also a floating value. In this case, you can create a 2-step control with hysteresis here as well. So our group trigger is a room temperature, 2-byte floating data point. And you program it, the group this way that you say, if I undershoot 21 degrees, then I activate 1 group. In this case, this group consists only of a telegram which are activating the heating, which is opening the valve, for example. So temperature is going up, going down again. And if you overshoot 24 degrees, that's the upper limit, then you deactivate the heating system. And the same if you undershoot 21 degrees as well. So it's a simple 2-step control with hysteresis. And of course, the thresholds, 21, 24 in this case, can be adjusted. And you can decide, you see, if I'm in area B over 24 degrees, then send out this telegram of this group. If I'm in area A below 21 degrees, activate another group. And in between, nothing shall happen, for example. Additionally to this component with the ETS application, we have an additional software available called PZM 2.1. What is this software? It's an external ETS independent software made for the end user. It's a software tool for the end user to adapt the application program from ETS created by the installer related to the ABZS. Please don't think that we can change anything in our ETS programming. It's only related to this application unit ABZS. Means time functions, but also group functions can be modified by the end user. That's new, normally not possible without ETS to change anything, but also thanks to the group functions, real functions behind could be changed. But there are some limits. Only group addresses already used in the ABZS can be modified with this tool. So the end user cannot take any other group address with any other function and create any crazy function maybe. He can only use the existing one, which are documented inside this tool, and then he should know what he's doing. The original programming with the ETS, of course, is always still existing and can be downloaded, of course, to come back or to return to the initial functions. So if anything is completely wrong with this software, then you can go to the further function always. It's a free of charge software. You can download it from our webpage. And a small explanation how it works practically. Of course, the installer is creating with the ETS project, including the ABZS programming. If he has done his job, he can export this file from the ETS, hand it over to the end user. This end user can use the PZM software, again, downloadable from our homepage. You need only Windows PC, can import this exported file from the ETS, can open, of course, this time program and this group program, and can modify this. And can download, of course, also from the PZM software via USB, for example, the new functions into the ABZS. It's possible. So it's a real, let me say, chance for the end user to change something, at least in this device. And that's relatively new, but sometimes in use, especially for the time program. That's interesting. So it's a very user-friendly tool then, and thanks to the Windows screen, you can work easily instead of any small, let me say, display and keypad at a timer itself, which also exists on the market. Yeah, a screenshot from this PZM software is very similar to the ETS plugin. Yeah? So same principle, but allow me to show this to you right now. I share now with you my application ETS, and then you can see what I'm doing directly in the ETS with this device. Just a moment. I have prepared already the ETS 5, the actual version of the ETS. Of course, works also still with ETS 4 and also with ETS 3, these components. But I would like to show you already the new version of the ETS. And ABZS is my component here. And normally I click here on parameter, and then you get the parameter window, but here it's a special plug-in software behind, so you have to open the product-specific parameter dialog right now. By doing this, it starts to plug in, and you're inside this special software for the ABZS, where you have the option to do something with time programs and with the group functions. These are the two different functions we have. Okay. Okay. First of all, some general functions available here. In principle, yeah, I don't go into all details, but allow me to show you this a bit here. If you activate a group with a lot of telegrams behind, or you have a time function, at the same time, a lot of function should take place. You have maybe a lot of traffic on the bus. You can delay artificially here with this function, or with this parameter. You can say between each telegram, I would like to have 300 millisecond delay. It's possible, yeah, if you want. The time program can be also activated, deactivated, if you want, completely deactivated if you want to any time, via a telegram. The internal or the operating mode of the clock can be internal. There's an internal clock inside. You have to adjust only once. Or as already mentioned, you can also use the slave function, means you receive them from any other clock, date and time, or you use a master function. Then you send out the telegram of date and time on the bus to synchronize anybody else. Both are possible. And if you decide internal, then you can go here and set date and time directly here. I can show you, okay, I have no component connected, but it looks like this here. You can read the PC time, and then you write it to the ABZS directly. Very simple to adjust the internal clock. Good, but let's come to the time program, time switch program. And the first thing you have to do, you have to create a day routine. Yeah, minimum 1 day routine you have to create. I do this. I can give a name, let's say working day. Yeah. You see also here the option trigger via bus. You can add a group address here to activate and deactivate this working day time program additionally. So maybe you would like to switch off the Monday program and it's not working at certain times. Also possible. But let's create first of all a simple day routine, insert, finished. So if I open here the day routine, I have created also already one day routine called the working day. More, of course, are possible. Let's take another one. Weekend, for example. And so on. 15 day routines are available. If you go to one day routine, you can add now the switching times. Very simple. You adjust the time here. Maybe 10 o'clock in the evening. And then, of course, you would like to say which group address shall be sent out at 10 o'clock in the evening. You have to select a group address. And if you click here, new group address, a window will appear showing you all the group addresses you have used already in the ETS. For example, for lighting on off, I have here group address light 1, light office 1. You have to click here on the middle group, then you select here the group address and accept this. Now you can confirm. At 10 o'clock in the evening, you operate light office 1 with which function, on or off is the option here. 1 is on, 0 is off. Up to you. Insert. And the first time function in the day routine working day has been set. Now you can say, okay, I need more. I need now at 11 o'clock another function, whatever it means, new group address. And I need now office number 2, accept, okay, but it should be switched off, insert, and close. So you see, at this time, with this group address, I switch on, in this case, light office 1, or I switch off light office 2. And so on. 800 switching times can be programmed. It's a lot. So what else do we have to do? Day routines we have to assign to week routine. Means our 7 days in the week have to be assigned to one of these day routines. How to do? You say, okay, on Monday, I would like to have the working day routine. Very simple. And now it's assigned. Yeah? You can take also more than one day. Yeah. Create here, sorry. Yeah. Okay, like this. And so on. So all days can be assigned to any day routine. And maybe on weekend, of course, we have a different day routine. Weekend, okay, and so on. Very simple. Yeah. It works like this. Okay, now every Monday, every Tuesday happens the same because these are our routines we have assigned. To overcome the situation, we can create special days. Yeah, for example, here, special day. What does it mean? Not only special day, but special period, you can say. I click twice on this, and now you can adjust here a period, whatever you want, from today until June, whatever you would like to have weekend program, because this is like holiday for you. And now at that time, it's different from the normal week routine. Only the weekend program runs. Either very simple to create any special periods or days. Daylight saving time, something I should mention as well. You can create here, if you have the internal clock, for example, there is no, let me say, possibility normally to have summer and winter time available. You have to say to this device how to do this. So you say for each year what happens with the daylight saving time if you have it in your country. Yeah. So you can go to the next day, and then maybe it's the same. You can calculate this automatically, and then you assign this here. Yeah, and you insert this, for example. If you have an external clock, like our weather station or weather unit, which can send automatically the right time thanks to GPS signal, you don't need this, of course. Yeah, finally, the overview. So for each group address used for a time function, you can have a look what happens with this function over a period of time. So from today up to next month, you can see right now what happens during the certain days with this function. It's always the same. At 10 o'clock, it will be switched off, for example, but during the working days only. You see, it's not very difficult. If you have understood once this principle, it can be done. And again, with the PZM software, the end user will do the same. He can create also anything, but he of course can also delete anything. So if I go to any working day routine here, I can go here with the right mouse button, click delete, and then I remove this type function, or I add new ones, either possible. But again, for the end user, it's only possible to take the existing ones, the existing group addresses. Yeah, not more. Good. Finally, I would like to go to the group function. Remember, a group is a collection of group addresses sent out more or less at the same time, triggered by another group address. We have to create a new group. Let's call it absence, for example. Yeah, absence is the name of the first group I create. I insert this. And then you will see here our first group with a trigger and member. The trigger is a group address to activate the group. Principal again, a group address. So let's take any group address. I take a new one. I have created already in the ETS. You see here my group address absence. I accept this. And yeah, insert this, of course. And now it's inside. Yeah. So this is my group address 313, which can trigger a group, whatever it is. I have to create group addresses as group members, of course. So again, I can choose the existing one. You see light again. Huh? If I insert a group address, you can decide what shall happen with this telegram. Shall it be sent as an on or off? In this case, on. And you can decide at which trigger function or which trigger value it shall be activated. Range A is off, range B is on. It's defined here for a 1-bit trigger. So I say if it's the trigger is sent with value on, then I switch on this light. Maybe the other light I would like to switch off, but also if I send an on telegram. But another function, whatever it is, light office 3, shall be switched on if there's an off telegram coming from the trigger, range A. So it's very flexible here, this creation of groups. So you see here the overview. I switch on the light if I'm in range B with a trigger on telegram, but I switch on the light in office 3 with value 0 of the trigger. So a lot of options you have here. And again, not only 1-bit, but also 1-byte telegrams are possible to be used here, both for the trigger and also for the members. 1-byte, 2-byte, and 1-bit is available. Yeah, okay, should be enough. Time is running. I'm a bit late, but no problem. You have an overview of all used group addresses, in which day routine, in which switching time is it active here. Is it in any group? Is it a group member or is it group trigger? You see here, good overview of the group addresses. And finally, the utilization means what out of the possible time functions and groupings you have used already. Remember, 800 switching times possible. Only one is used at the moment. Yeah? Only one group out of 30. In total, we have 300 group members. Okay, if you have done your work, then you can export this here into a file, ZM2. And this can be then handed over to the customer finally, and we can import this into the PZM software if you would like to change something by himself. Yeah? That's a way to hand over to the customer. Okay, good. Allow me to close it here. Back to the ETS, but now I would hand over to Jürgen, who would like to show you something around the ABLS logic module with, mainly logical function, but also a bit more.
Hello and warm welcome from my side. My name is Jürgen Schilder. Thanks for being on time, and I would like to continue the second part of the webinar and introduce you the so-called application unit application unit logic, the ABL/S. So what can we do with this application unit ABLS, the logic module? So with the device, we can fulfill a lot of functions in our projects. So per device, we have so-called logic modules or logical functions like AND, or we can use so-called hot gates. We can use the unidirectional or bidirectional gates. We have additional timers, comparators, and of course, we have different up to 200 worksheets. So we can have all these logic elements inside our graphical environmental. So in the next slide, you will see that we have here not only parameters like a standard KNX device, so we have a graphical environment. So this graphical environment runs inside the ETS in a so-called plug-in software. It's the same if you use ETS3, ETS4, or ETS5. So like here's a screenshots of this graphical environmental. It is based on the German standard 40900, and it shows you, or it gives you here an overview of your logical functions or logical elements. So we have here so-called input elements. We have at the end, we have output elements, and between we have our gates, we have our timers, we have the AND or the logical elements. And we are inserting the elements and linking element input element here to our gate, for example. We can link the different elements together, and via mouse click, we can add group addresses. How we do it, I will show you later. So of course, we have here a lot of elements or group of elements, and we have additional here feature inside to copy the elements or the group of elements. Now, when we go back, for example, when we quite often use here this group of these linked elements, then we can select all these elements via the mouse. We can click on the button copy, and then all these marked elements are now copied in our clipboard, and later we can paste this copied element in our project. By using this copy and paste function, the group addresses are not copied. It's very important. All elements which are linked together are copied, but no group addresses. So after we have pasted our new our group of elements, then we have to assign manually the group addresses. I think this is a good feature. So we can when we don't copy and paste group addresses, because then we can manually add your group addresses, and you are sure what you have done. So to link our input elements or the different logical elements, we use, for example, also here our mouse. We click here on our element and keep pressed our button, our left mouse button, and link it here to the, maybe also to an input of our element. And then you can see here there's a combination or a link between this input element and here our input S on our logical element here. So, but when we add here another or link another input here to this input of our element, and then the ABL prevents so-called maybe a cross link. Yeah, so he makes here interrupt. He places here a marker. He starts with the marker 0 and continues here on the element with the same marker 0. So you see that this marker 0 and 0, this should be aligned, but it is here interrupted, that you get not confused, and you have here a clear overview of all linked elements. And the same later when you click here, for example, on a marker, and then all other markers with the same value 0 are maybe marked, and then you see this input here is linked to also to several modules, for example. And to unlink, you click here maybe on the marker, or you click on a line and press the delete button on your keyboard, and then here this line from here to here maybe will be unlinked. So let's have a look at our inputs and outputs. The first step is we click here on our input and assign or insert these inputs and outputs here in our graphical environmental. So on this here describes also our communication objects. And such an input can be a 1-bit, a 2-bit, 4-bit, 2-byte, or 4-byte size. So later, via the right mouse click, you can parameterize your 1-bit communication object, or 2-bit or 4-bit. And now here my example, this is my communication object, my input number 0. It is a 1-bit information. And then you can see here in the ETS later communication object, you can see here the object number 0 has here the value a 1-bit information. And now when you change here the input number 2, for example, to a 4-bit, and also here the communication object number 2 will be changed to a 4-bit communication object. So how we can link group addresses to our input elements or output elements. So we click here, for example, on our output element, right mouse click, and then the window pops up, and we have here the possibility to click on this menu here, link to a group address. So we click here, and then a new window pops up, and now we can assign here group addresses to our output. We can use our existing group addresses, which we have created or added before in our group view, or we can here create a new group address. Now, when we click here, then we can write here the group address and also the description or the text of this group address. So we select here this group address, the existing group address, press here on the button OK, and then you will see that our output communication object is now linked to the group address 120. So later, when here this element calculates a new value, this output communication object sends this group address with the according value of the object to the KNX bus. So some parameters of the inputs. Now when we click on an input element, right mouse click, we can also here link group addresses, or we can edit here some parameters. The default value of this input element is now a 1-bit. So by selecting here our 2-bit, 4-bit, 1-byte, 2-byte, or 4-byte, you can change here the type of this communication object. When you select, for example, a 2-byte, your size of a 2-byte, then you can additionally here in the subtype select the value. It is assigned, it is unsigned, or it's a float value, for example. So on our output, we have also some parameters. So now you click here on our output element, right mouse click, parameters, and then we can select here also the size, the type of our output, the same 1-bit, 2-bit, 4-bit, 1-byte, 2-byte, or 4-byte value. And again, here the subtype, if it's a 1-byte, 2-byte, or 4-byte. But here it's a very important parameter. When does this element should send the telegram to the KNX bus? Only on alteration, which means when the value changes from 0 to 1, or from 1 to 0, or if we have a 1-byte information, but the value must change. Then he sends this value, this KNX telegram, to the bus. Or we can use here another parameter on each calculation means he sends, of course, the information to the bus if the value changes from 1 to 0 to 0 to 1, plus every time when he gets here a new maybe result from our element. So also when he receives here a 0, then he would send it to the bus. A 0 again, send it also. So this is very important because later when we call a scene, for example, I show you an example, then every time we send the same scene value, scene number 5, scene number 5, scene number 5. And then we have to select here, or we have to use this button on each calculation. So keep in mind, when you do your own logic and it works only one time, then please check this parameter. Maybe this is the failure because you have select here, not each calculation. So let's have a look at some gates. I would like to start with the so-called AND gate. So AND gate, we can have up to 8 inputs. So we can enable maximum 8 inputs, and our output, for example, is according to the AND gate standard, which means only if all inputs have the value 1 or high, and then our output has the value 1. If minimum one of the input is low or has the value 0, then the output goes back also to 0. This is standard principle of an AND. Additionally, we can negate or invert all of our maximum 8 inputs, and of course we can also negate or invert here our output. This is standard gate function. So additionally, we have an OR gate. OR gate, maximum the same, 8 inputs. We can also negate or invert each of the input, and of course the result here in our output. The principle of an OR gate, the output is 1 or is high if minimum 1 of our inputs here is high. 1, the first one, the second one, or all inputs are 1, and then the output here is also 1. So another nice feature is a so-called one-hot gate. So what on a hot gate, we can have again up to 8 inputs. We can negate the inputs and the outputs. But the logic of a one hot gate, you can see here if we have 2 inputs. So one hot gate, the output is hot or has the value 1 if exactly one of our inputs is 1. Like for example here, input A is 0, input B is 1, and then the output is 1. Or here vice versa, input A is 1, input B is 0, then the output is 1. But when both inputs are 1, input A and B, and then the output is 0. So this is a principle of one hot. If exactly one of our inputs maybe is hot or has the value 1. The same here when you say now we have 3 inputs, and you see exactly the output here is 1 if exactly 1, here only the C, here only the B, or here only the A is 1 or is hot. That's the principle of a one hot gate. Don't mix it with an exclusive OR gate. This works a little bit different. Here in our application unit, we have the so-called one hot gate, but in the LMS logic module like before, we have the exclusive OR, which works nearly the same. In principle, the one hot gate is hot if with exactly one of our input has the value 1. This is nearly the same in our exclusive OR gate. So you will see here input number C is 1, then here our output is also 1, or only B or only C. But it is specified that the exclusive OR is very important. When there's an uneven number of inputs which are on, then the output is always on. That's the difference here against our one hot gate. For example, here we have uneven number of inputs. We have 3 inputs, 1, 2, 3, and all inputs are 1, and then the output is also 1. This is a special behavior of an exclusive OR. So be careful and don't mix it here. This is one hot, like we have it in the ABL, and this is exclusive OR, like we have it in the LMS. Good. So the next nice features, we have so-called gates. I would like to start with the unidirectional gate. A gate is like we have, for example, here we have an input. Input, here comes a group address, and here in the output, we can also assign a group address. So what is very important that both must have the same size. So we can have here 1 byte, here 1 byte, or here 4 byte, or here 4 byte. And depending on our control input, this gate is open or closed. For example, here, our gate, maybe when it's closed, the gate receives a telegram, but it is closed, and then on our output happens nothing. We can open here our gate via a 1-bit telegram, and then the gate is open, and then when he receives here a telegram, he forwards this telegram here with another group address, but with the same value. So depending maybe here on a situation, we can stop or block telegrams, or we can forward it into a new group address. That's very important. And the size we can here forward of group address, it can be 1-bit, 2-bit, 4-bit, 1 byte, 2 byte, or also 4 byte telegram. So how does it work? So we have here, for example, in the unidirectional gate, it's a one-way communication from our input to our output. The input is left, the output is right. So we assign a group address to our input, like our 1/459 with the value 1. So our gate is now disabled, it is closed. Here we are our control input, and then on our output, nothing happens. We have no telegram. Via a telegram, a 1-bit telegram, which receives here our control input, we can enable or we can open our gate. And then when he receives here on the input the group address 1/459 with the value 1, he forward it to our output with another group address like 3 to 174, but with the same value. The logical 1 we have here in our input, we have also here on our output. Or maybe he receives the same group address with the value 0, then he forwarded it into a new group address with the same value. So depending here on our control input, this telegram here is blocked, or maybe it is forwarded into another group address. That's the behavior here of our unidirectional gate. So we have some more features. When you click on the right mouse click, can you see the parameter of our gate? We can here also negate our output. So what does it mean? When our gate now is closed, you receive this telegram. Of course, our output, nothing happens. But when our gate now is open, he receives this group address with the value 1. Then it is forwarded into this group address, but with the value 0, because the negation of 1 is 0. Or he receives a telegram with the value 0, then this forwarded into this group address with the value 1. So here with this negation function of a gate, you can negate KNX telegrams. Sometimes you need this, for example, in a typical intrusion alarm system, the value of your alarm system is 1, the system is set, and when the system is unset, you have the value 0. But when you want to trigger something with the unset information, then we can negate it, and then we have also group address unset with the value 1. That's a typical example for negation of telegrams to use this gates. Or we can filter telegrams. Yeah, a 1-bit information, you have the value 1 or 0. But sometimes you need a group address every time with the same value, only 0 or only once. In this case, you can use also here the gate. So when you click on the gate, we have here a parameter which is called filter. We can select non-filter, or we can say pass-through object value 0. Then he forward only the telegrams with the group address value 0, or here pass through with the object value 1, and then only with the group address value 1. So like, for example, here, the same, our gate is closed, our control input is closed, then nothing happens. So nothing happens here on our output. But when our gate is open, our control input is enabled. He receives the telegram with the group address 1459 with the value 1. But now we have set here parameter pass through object value 0. And then this telegram is not sent here to KNX bus. Only when the same group address now will be received with the value 0, and then the group address is forwarded, converted into the 3 to 174 here with the 0. So here in our output, we have always only this telegram with the value 0s. The 1 is blocked. So this is also a nice feature. Sometimes you need it to filter telegrams. So additionally, parameter of such a gate is, for example, you can say no, none function. What does it mean? When our gate, for example, here is closed or blocked, here he receives a telegram, nothing happens on our output. So when the gate is now enabled, and then with the next telegram, on our input, it is forwarded to the output. But we can have also a nice feature, which is a parameter called save during blocking phase. Now the telegram on the input now will be saved. And if we enable our gate, it will be forwarded to our output. Now, what does it mean? Like here we have a typical example. We have our gate. We have on our output, we call a scene in our shutter actuator, for example, our scene number 5. So we have here the size of 1 byte. On our input, we have our weather station, which calls our night scene. Must be also a 1 byte information. And on our control input, we have the information which comes from a magnetic read contact. Now the door on our balcony or on a terrace, when it is closed, this value is 0. And when we open our balcony door or the door on a terrace, then the value is high and sends the value 1. And now we are inside a building. Our balcony door is now closed. So this value is 0. It is negated here in our input. And then now our gate here is open. So when the weather station calls in the evening our night scene, this telegram goes here inside our gate. The gate is open and now is forwarded here to our actuator, and the shutter drives down. But now during the summertime, we sit outside on our terrace or in our garden. We open the door to our balcony. So we send here the value 1 here to our gate. It is negated, and internally he receives the 0, and now the gate is blocked. In the evening, or it becomes night, the weather station calls the good night scenario, but now the gate is blocked, and telegram here, the value is now saved. So we go back inside our living room. We close the door of our balcony, and then this value becomes 0, internally negated, and now the gate becomes open, and enabled. And then he sent to the output the last value he received during the blocking phase. And then with closing our balcony door, he sent the information to our shutter actuator, and the shutter drives down. There's a nice feature we can use, for example, here in our unidirectional gate, save during blocking phase. So the next step of gates are so-called bidirectional gates. This is nearly the same like you use 2 unidirectional gates, which works anti-parallel. The only difference is here a bidirectional gate is we cannot filter telegrams. That's the only limitation. In principle, we have here input and output on the left side, and we have an input and an output on the right side, and we have, like before here, our control input. And depending our control input, we send a telegram here from this input to this output right, or from this input to the output left. So it works in both directions. And here again, both sides must have the same size of communication objects, like 1 bit, 2-bit, 4-bit, 1-byte, or 2-byte information. So this is the example here. At first, we can, for example, disable our gate. So here our control input, maybe it is low. Then we can send the telegram from the left side to our gate. It is closed. Nothing happens on the right side. No group address is sent from KNX. And the same when I tell the telegram on the right side of our bidirectional gate, it is closed, and then he sent no information to the left side. So now when we open our gate, so via our control input, and we have on the left side a telegram with the group address 1459 with the value 1. And then he sent the group address, which is linked on the right side, with the same value here to our KNX bus. Or vice versa, we receive this group address on the right side with the value 0, and then he sent it to the left side of our gate to the KNX with this group address 1459. It can be a 1-bit, also a 1-byte, like for example here on the left side, we have this group address with the value 87. It is sent into the gate and leaves the gate on the right side with this group address and the same value. So you can see it works nearly like two unidirectional gates, like anti-parallel. That's the principle here of these bidirectional gates. So additionally, we have another element which is called a timer. A timer, we can have here the parameters, for example. We can use additionally filter functions, the same like before. We can filter 1 or can filter 0. And here we can set a time for switching on delay, off delay, or we can use a kind of pulse duration. Here you can see the feature of our on delay. So TE means the on delay. So he receives on the input the value 1, and then our on delay time starts. And after, like example here, 2.5 minutes, then he sends the value 1 here to KNX and switch maybe your fan or your blower delayed on. Our off signal will be transmitted immediately to the output. And here our off delay time, like for example here 5 minutes, the same principle. On the input, he receives the value 0. Then the off delay time starts, and after 5 minutes, he sends this off signal, the value 0, here to KNX or to the next element. That's the feature of the off delay. On delay is not available because here I have the 0. Of course, you can combine both, like here on delay 1 minute 10 and the off delay time 8 minute 45. It means he receives on the input a value 1. Then it's the counter, the timer starts internally. After 1 minute 10, the 1 is sent to KNX bus. When he receives the 0, after 8 minute 45, the 0 is sent now to KNX. So what about this pulse duration? Pulse duration, it works like a principle, a staircase. Like here in the input, he receives the value 1, and then the 1 minute 50, our pulse duration starts. And after 1 minute 50, he sends the off signal, the 0 here to KNX bus. This works like a staircase function. So here we have additionally our typical staircase light. So it has only one input, which is also together the same, also an output. So you specify here your staircase like time. So the staircase line time is triggered with the value 1. And after 4 minutes and 10, for example, he sent the value 0 to our output. This typical staircase function we have in our actuators. So the next element is a so-called comparator. Via comparator, we can compare two input values. This can be 1 bit or 1 byte, or also a 4 byte, or typical 2 byte temperature. So, and depending on the temperature, we get at the end a result, and the result now is sent as a 1-bit information to KNX, as it is okay, or for example, it is fulfilled or not. So just a second, I have here some problems with my mouse. Thorsten, can you help me? I cannot see my mouse on the screen, sorry. Here's it. Okay. So here's it again, yes. So we have, for example, here our two inputs, and then we have here, we can compare our two inputs, and then we send it here to our output, the result, if it's 1, if the result is okay, or the 0, if the result is not okay. So additionally, we have here a kind of error output, maybe when the value overflows our output value. So now we can have a lot of our logical gates and our gates and inputs and outputs in our graphical environment. Don't get confused. We can use such kind of worksheets, and via the worksheets we can divide here maybe, or we can work with different group of elements. And depending on our worksheets, we are more flexible, and we have here a clear overview of all used our elements. Good, then I would like to start only 1 or 2 minutes and show you here the feature how we can create such a logical gate inside the ETS. So I have to share here my desktop. Okay, click on the parameter. So now when we click here on the parameter, then the menu pops up and you can see here our plugin software, which looks similar if you work with ETS 3, 4, or 5. First step is we click here on our input via drag and drop. Now we insert here an input, a next input, second input may be here. Then we use a gate, click on the gate, via drag and drop the gate, and we need minimum 1 output. So first step, we can set a parameter for our input. Of this input, right mouse click, for example here, edit parameter, and then we can specify the size, URL 1 byte, for example. So our output must have the same size. Like here, I click on edit parameter, here 1 byte, 1 byte, okay. And then I can link here the input, the first input element with a 1 byte, and the output element also, which is a 1 byte to our output. And our control input must be a 1 information here to this one. So this is our first gate. Right mouse click here, for example, of our parameters. You can write here name of this gate, XYZ, for example. When is the control input released? With a logical 1 or with a logical 0, or for example with a 1. We can use no filter. Filter is only possible when we have 1-bit information on our input and output. But here, for example, we can use save during blocking phase or with sender trigger. No additional function. And the last step is we have to link group addresses. Right mouse click, link to group addresses. Then our group addresses will pop up here. You can create a new group address if you want, or you can use existing in all the lines or which not I used before. I select here one of my group address, like for example, here like my Office 1, click on the button OK. Oh, wrong type. I have to use a one byte, sorry. Edit parameter, sorry. Link group address, link to group address, existing group address, a group address which is not used before. Let me use, for example, this here. And then you will see my input element here is now linked with this group address, and I can do the same with my output, and for example here with my control input group address. This must be a 1-bit group address, link to group address, existing group address, like for example absence. Okay, and now when I'm absent, let's link it here to another group address, for example. This one, for example. And depending on this control input, if the value here is 0, this group address now is here blocked. But now when I enable here my input, so I'm absent, which is the value 1, this gate is open, and this group address now goes inside my gate and is forwarded to KNX with this group address of the same value. Good, so far the principle, input, insert inputs, outputs, and link the elements here with our input element and the output element, and save. Click here on the button, and then you will see here also on the communication objects here my ABL, my input 0, 1, 2. You can see the assigned group addresses and here the length of our data. Good, so far a small introduction, and now I would like to show you some examples. Examples of this ABL when we need it or how we can use it. For example, one solution is to convert a 1-bit telegram into a 8-bit, like for calling a scene or when you want to have a fixed brightness value. Like here we have the information with the value 1, it is rain. It is a 1-bit information, and then we want to call our KNX scene number 8, for example, which is a 1-byte telegram. How we can use it? So we use here our gate on our input, our gate, we have to set a parameter. We use here now our feature save value with sender trigger. What does it mean? We set here default value on our input. And every time we send here the value 1 to our control input, and then we trigger this value, which is here stored on our input. So every time he receives here the 1, rain, 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 and then he uses our default value and send it here to our output module. That's why we have to use here this another parameter, save value with sender trigger. So our input we use here, it must be also a 1 byte size. We specify here our initial value, which is 7, which means our KNX number 8. And our control input, here we have the information, rain, which is 1. And we have here additionally on our output, also group address as a 1 byte. But here it's very important to use the parameter on each calculation. So and now our system works like this. When we have no rain, so we have here the 0, then nothing happens. And now we have rain, then he sent here the value 1 to our input. And every time here the allocate receives the 1 on this input, then he takes this value, which is fixed, the value 7, and forwarded it here and calls our scene number 8. So via this gate, we can convert a 1-bit information, rain, into a 1-byte information. But be careful to use here the correct parameter. Or for example, here kind of light scenarios, like in a sauna or in a spa or in a hospital for light therapy, for example. We have red, blue, green, purple, yellow color, different, for example. How we can use it? We create scenes or scenarios. One scene is, for example, our color red, one is the blue, one is the green, one is the yellow. We can use endless number of scenes. But here in this example, we have 3 colors. So we have to create 4 scenes, 1 scene per each color, like here, for example, purple or green or yellow, and 1 scene, for example, to switch off all the lights. So via 1-bit information, via a typical push button, we can start here our so-called sequencer sequencer element, and then every 10 seconds he calls another scenario. This is a very easy solution to use, for example, this principle. So with a 1, we start, our sequencer is running and calls the scene every 10 seconds. And when we press here the button off, the sequencer stops and switch off all the lights. So this is a logic which is also often used. But here, remember on our output, we have to set here parameter on each calculation because the scene number here is every time the same. Or here another example, like in a hospital. Hospital is sometimes required that during the day, the light can switch or dimmed up to 100%. So when you switch on the light in the afternoon at 3 o'clock, the light is on 100% and will not go off automatically. But when it becomes 10 o'clock in the evening, the light should go down to 50% and stay at this value 50%. But during the night, when someone presses the push button, the light should go on to 100%, but after 5 minutes back to the default night value 50%. So how we can use it? For example, we use our dim actuator, and we need here also additional gate. So and via the gate, for example, we can via the night mode we can trigger this time function. So now during the day, we press our button, we send the group address straight to our dim actuator 001, and we switch on the light 100%. And now it becomes 10 o'clock at the night. Then our time switch sent here the value 0, which means it is now night, 10 o'clock. It is here converted. And then our time, our result here, the 002, is now linked to our staircase function, and the time runs 5 minutes. After 5 minutes, he sent this telegram 004 here to our brightness value, to our present, and then the dim actuator goes to 50%. And via the button, every time we can trigger here our 100%, but after 5 minutes, it goes back to the 50% night mode value. Good. Or here, if you want to have a flashlight, the same example, we need an end and a timer. And a timer, we can set here the on time for on delay and off delay, for example, every time 1 second. And every second we have on, off, But here it is recommended to use the settings only on alteration at the output. Because when we stop here, we are the value 0, our flashlight, and then we have no telegrams here on the KNX bus. When you make a mistake and you see on each calculation, then you have every second, if the timer is on and off, here you are off signals. So be careful. Good. And last but not least, our typical example of the ABL gate function, the partition wall. Like here we have maybe a large room, open office, yeah, or meeting room, and via separation wall, we can use, for example, here this as a bigger room. So we have a sensor in this room, we have a sensor here in this room, and when the separation wall is closed, which we get the information via magnetic read contact, this sensor should only switch and dim the light here. This sensor switch and dim the light here, and this sensor only here in this room. And now when we open this separation wall, we get the information via the magnetic read contact. This sensor should switch and dim the light here, and at the same time here in this room. And of course, this sensor switching dimming this light, and of course here in this room. How we can use it, how we can realize it, very easy. We have different kind of solutions, of course, but the easiest way is we use our gates. So one gate between room 1 and 2 for switching, and one gate between room 1 and 2 for dimming. So we use bidirectional gates. We link here the group address for switching on the left input, output, and on the right side, the same for group address for switching the light in room number 2. And here we link the information which comes from our magnetic read contact. And now when our separation wall is closed, this telegram comes from our sensor number 1, stops here, but when our separation wall is open, it is forwarded into or converted into this group address and now controls the dim actuator in the second room. And the same works also vice versa in both directions. This is, I think, the easiest way. One gate for switching, one for dimming. And between room 2 and 3, we use additional the same logic. But when all two separation walls are open, with this sensor, we want to switch and dim here, here, and here, and then it still works. So we press here our button. He sends this group address. It is converted into this group address. The light in room number 2 goes on and off. It comes here to this gate, goes inside this gate, and switch and dim also here the light in the room number 3. So this is, I think, the easiest way. Good, so far. For more details of our devices for application unit, time, logic, LMS, please visit our website, abb.com/knx. Go to the menu, the topic number 10, control, logic, and time, and you will find more details, all needed information of all these devices. Also the PCM software, like here, we are in the menu of the application unit logic. You get here also the ETS3, ETS4 product files, the photos, technical data, the handbook, for example, and of course the software, the Net Framework 1.1. The ABL needs the Net Framework 1.1. Today there are newer versions available, but you still need the Net Framework 1.1. So if you have not installed it, please download also here .NET Framework from our website. Good, what about the next training here in Heidelberg? We still offer webinars, but also here some classroom trainings in Heidelberg. One is in July from the 6th up to 10th. This will be our next KNX certified advanced training. This is not our ABB product training. It is specified by the KNX Association. It's a 5-day training, and we will do some topics about HVAC, integrated applications like scenarios, couplers, IP. Of course, the ABL is one part here of this training, metering, multimedia, and so on. So remember the date, 6th to 10th here, 1 week in Heidelberg. But to attend this training, you must be a KNX partner, which means before you have to attend a basic training. So the advanced training requires at first a basic training. So after this training, from Monday, the following Monday, Tuesday, we offer our KNX ABB application training. So here we are flexible, and we introduce you here new devices or new special applications depending on the attendings. And here, for example, you can see the picture of our last certified basic training from February this year. We have here very international attendees from El Salvador up to Morocco, Belarus, and here our colleague in Korea, South Korea. So it was really a worldwide group, and it will be nice that we have also a lot of attendees here in July. The next webinar will take place on the 1st of July, the same day, Wednesday, same time, 9 o'clock in the morning, German time, and 3 o'clock in the afternoon. The topic now is DALI, Digital Addressable Lighting Interface. We would not to talk about our gateways. We have done it before. We want to talk about the basics. What is DALI? What about the key facts, the technical data, the traffic on DALI? What happens behind? So because a lot of customers, they use still DALI, but we need here also or we want to transmit also knowledge here behind what you have to know before you start with working with the gateways. So remember the date, of course, we will send you invitation letter, and I think we can close now our webinar. Thanks again for taking part. Have a nice day and goodbye to all.
Okay.
Goodbye. Goodbye.